Today I will review the backstory that led to the origins of NeoCorr Engineering, and how the integration of advanced multi-phase pipeline flow modeling began to be integrated in innovative corrosion hazard profiling, and how this approach continues to provide an industry-leading foundation for risk-appropriate corrosion management plans and pipeline inspection planning. This is a story from my early days as a young engineer in training at Shell Canada during the 1980s. Back then, one of the expectations for new engineering graduates was to enroll in and successfully complete a master's level engineering program at the University of Calgary focused on gas processing and oil field facility design. I share this story because it's the foundation of a realization that would shape my career in the years to come. After 8 years with Shell, providing field support for pipeline operators, gathering system corrosion assessments, and inline inspection programs, I moved on to join a small independent chemical company, Travis Chemicals. My role there was to support oil field operations by assessing corrosion risks, designing chemical mitigation programs, and helping operators succeed in leak prevention and program optimization. The role was demanding. A typical month involved 7,000 to 8,000 kilometers of driving, covering Alberta oil fields from Taber in the southeast all the way to Zama in the northwest, even reaching Fort Nelson in British Columbia and Cawdon Ely in the Yukon. I worked across varied terrains, from the deep foothills in the south from Waterton, Jumping Pound, Ram River, Strachan, and beyond. Early in my tenure at Travis Chemicals, I found myself standing in the Elmworth field in the Wapiti Valley, southeast of Grande Prairie. It was an operation managed by Canadian Hunter Exploration, and they had just experienced an internal corrosion pipeline leak. Naturally, the question arose, where would the next failure occur? Standing there, surrounded by this vast network of wet gas gathering pipelines, the enormity of the challenge struck me. It was clear that our ability to predict the next failure was limited by the tools and knowledge we had at the time. And that brought me back to those courses, the exposure we gained to pipeflow and to the science of pipeline multi-phase fluid flow modeling, ideas that had been planted a decade earlier but had yet to bear fruit. The question of which pipeline is next to fail wasn't being answered effectively by traditional industry methods. At the time, the rule of thumb was to classify pipelines based on critical velocity. But this method wasn't working. Failures were still occurring unexpectedly, causing significant stress for operators and chemical providers alike. I realized that the crux of the issue lay in our lack of understanding about water movement within these pipelines. It wasn't enough to know about gas flow. We needed to understand how water behaved, whether it moved as a fast-flowing stream along the bottom of the pipe, or collected in stagnant low spots. These stagnant regions, where pH could drop and solids could settle, became microenvironments of intense corrosion. It became clear to me that improving our ability to predict pipeline failures required a deeper understanding of the flowing environment inside the pipe, specifically the behavior of water films. That realization became my focus for the years ahead. Fast forward to April 1994. That's when I decided to leave the chemical company and connect with Gary and Ed at Neotechnology Consultants. They were part of a global network of experts dedicated to modeling three-phase flow and multi-phase gas and oil gathering systems. Working with them was a game changer. By leveraging advanced flow models, we began to uncover critical insights about how water moves or doesn't move within these systems. This understanding allowed us to better classify pipelines based on their vulnerability to internal corrosion and to design more effective corrosion management plans. By characterizing water flow and identifying stagnant water traps, we elevated the industry's ability to classify pipelines with greater accuracy. This wasn't just a technical improvement, it was a fundamental shift that helped operators prioritize mitigation efforts, reduce failures, and enhance the reliability of their systems. That's how it all began for me, with a simple but profound question in a vast field in the Wapiti Valley: which pipeline is next to fail? Being dedicated to the development of innovative methods to help field ops and chemical teams better answer that question has been my mission ever since. Thank you for joining me on this journey today. If you're as passionate as I am about pipeline integrity and corrosion management, stay tuned for more stories and insights from my 42-year career within our Trusted Pipeline Advisor podcast series. Don't forget to subscribe and share this podcast with others in the industry. Together we can continue to improve and innovate.